Hi, this is Jerry Griakos, UR14CS317. This is my experiment number 5 for the System Software and Compiler Lab. So this experiment is a simulation of the DFA, Deterministic Finite Automata. So here we ask the user to enter a transition table, and from the transition table, we also ask the user to enter a string, and we compare to see if that input string is accepted by the deterministic finite automata, and if the output is accepting, we print that, and if not, we print that scenario. So we'll take a look at the program. So this is the program. So we have the package name, we have imported the scanner class, and inside the main function we have included an array. Array's name is A. It's a two-dimensional array with size 10 into 10. The name of the array is A, and we have included the scanner. We have initialized the scanner class, and we ask the user to user for the number of states. In that particular value, the number of states is entered into the variable x, which is of type int. It is being read into the variable x using next int. We also ask the user to enter the number of characters. So we enter that value into the variable y, which is of type int. Then we ask the user to enter the transition table. So we saw that we have a two-dimensional array called A. So since it's two-dimensional, we use two for loops, one for the rows and one for the columns. So using two variables I and j, we declare the two-dimensional array by inserting the values that the user enters, and it is done using the statement a of i comma j is equal to in dot next, and caret is to read the first character that the user enters for each cell in the two-dimensional array. So then we ask the user to enter the final state, and that final state is taken into the character variable fin, and one character is being read, the first one. So we use the function caret. Then we ask the user to enter the starting state. So we take that variable into start. This is done also using caret function. Then we declare a variable s, which is of character type, and then we set that variable equal to the start value that the user entered. This is for a backup to be compared at the end. So we start a while loop where each time the start value changes. This time it is the s value, which is the starting value that the user have entered. Now we ask the user to enter a string. This is for each time the user wants to check if a string is accepted by a deterministic finite automata. So whatever string that the user enters is being taken into the string variable called st1, and it is being read using the function next. And that particular string that the user entered is being split into character array. This is done using the function toCharArray. So it is stored into the character array with the name st1. Then we have declared two variables g and h, and using a for loop, we convert the values into the ASCII values. So we convert the value of the starting and the other variable that we entered. So we have a new set of positions g and h, so we get integer values for that, and the start is being reinitialized to a of g and h. So g and h will either be a position as the position of a cell in the particular table. So we continue that until the length of the string is over, length of the character array is over, and then at the end we check a condition each time whenever the while loop is executed. We check if the start or the start position that we saved in that last loop, that is equal to the final position or the final state that the user entered. If that is the case, then we know that the string has been passed through from the left to the right, and all the items in that particular string is being accepted through the DFA. If passing through the particular DFA does not, or the string does not accept the conditions of the DFA, then we print that this st1 or the string that the user entered is not accepted. So we'll run the program and see. So enter the number of states. So we'll have 4 states. Number of characters will have 2 characters. We'll enter the variables for the transition table. B, A, B, C, O, C, B, D, B, A. And the final state is D, and the starting state is A. We'll enter the string that we want to check for. AABB is a string that we check for, and it says that the string is being accepted. And we'll check for BABB, which is something that should not be accepted. And as it is correct because it's saying that BABA is not being accepted. So that's it for the 5th program of Compiler Lab.